Hi, my name is Ava and I am making this video for my Biomedical Innovations class. We have an independent research project that is completely our own, so I decided to make an informational video talking about tissue engineering. If you're watching this, you are one of my classmates and this is a weird meta fourth wall thing that's happening, or you're a random person who found this video on YouTube. Regardless of who you are, I just wanted to talk about tissue engineering as it's particularly interesting to me, and at the end of this video I just hope you learn something. So for some context, I've been involved in my school's biomedical science program since I was a freshman. When I was in 8th grade, the program was new, so when I was a freshman it was the first year of the program at my high school. So the class of 2022, aka my classmates and I, will be the first class to ever complete all 4 years of the program. And I'm so happy I took a chance and decided to take the first year of the program and then continue for all 4 years, because I would honestly have no idea who I would be, where I would be, and what I would like. And then without this program, and I really fell in love immediately, and over the last 4 years I've learned so much more and my love for biomedical science has just grown more and more. So shout out to Mrs. Rohr and Mr. Zalonis, the two teachers I've had. You facilitated an environment where I can really explore my interests, and shout out to you, thanks. Tissue engineering specifically piqued my interest because of how wide the field is. It encompasses a lot of the things that I know I already like genetics and genetic disease, cancer, the life and death of a cell, plenty of other things that I'm interested in. But tissue engineering is such a wide field that encompasses things I already like. The possibilities are really endless in the field as well. You can build organs from the ground up, build miniature organs, more on that later. And we can even produce clean meat, which I don't talk about in this video, but could be a whole other video within itself. Tissue engineering also particularly fits with my goals in the future. I have a desire to help people, but less so in the sense that I'm working one-on-one with a patient like a doctor or a nurse would. I'm more of a helper from behind the scenes. And tissue engineering develops technology to help patients, and that's just what I see myself doing. Tissue engineering is a wide and ever-changing field, and I just hope to do something to help people and be a part of the field. So in short, tissue engineering is just a wide field that encompasses a lot of the things I already know I like, and when I was researching for this, I was just finding more and more things I was interested in and wanted to know more about, so I decided to make a video about it. Last disclaimer before I get into what I'm talking about, I'm not an expert, I'm just a high school student talking about a topic I'm interested in, and I've done my research thoroughly, but it's a hard concept to understand, and I just use some grace as you watch this video. So what even is tissue engineering? A lot of people don't know much about it, but that's okay, I'm about to tell you. Tissue engineering is one of the many disciplines or subcategories underneath biomedical engineering. So some of the other disciplines include the design and development of medical devices, clinical engineering, and biomedical signal processing, just to name a few. But for tissue engineering specifically, the goal is to restore, maintain, or improve damaged tissues. The way this is accomplished is through a wide berth of knowledge that frankly flies over my head every time. It's pretty complicated. You need a lot of biology, chemistry, physiology. You just need a lot of information to understand the nitty-gritty details of how it works. But in this video, I'm going to give you some insight to how it works on a more macro scale, and you can understand what it is and how it works, and some other interesting parts about tissue engineering. So before we can jump into tissue engineering as we know it today, we first have to understand how it came to be. So the first ever historical reference to tissue engineering was in a painting by Fra Angelico called The Healing of Justinian. Fra Angelico created this early Renaissance religious painting in 1438 to 1440 in Florence, Italy, and the painting depicts Saint Cosmas and Saint Damien transplanting a homograft limb onto a wounded soldier. So a homograft limb means just a healthy human leg to replace the soldier's wounded one. And I'm not sure how successful this operation was, given that Cosmas and Damien are saints, not surgeons, and although they can perform miracles, the medical practices of the 1400s were rudimentary. 1400s doctors poured wine on wounds, and that tells you really all you need to know. But anyway, the term tissue engineering, as we know it today, was first used in 1991, only 31 short years ago. But before that, throughout the 70s and 80s, the term was loosely applied to prosthetics and surgical manipulation of tissue. In the early 1970s, pediatric orthopedic surgeon W.T. Grain correctly concluded that new tissues could be created by seeding viable cells onto a scaffold. That sentence probably has some words, you don't really know what they mean, but I'll explain them in just a second. But the key point of this field emerging was when Dr. Charles Alfred Vacanti approached Dr. Robert Langer of MIT with an idea to create an appropriate scaffold for cell delivery as opposed to the natural scaffold of the human body. So think of a scaffold and seeding cells onto a scaffold kind of like vines growing. If you let vines grow without intervening, they might grow all over the place, they might grow into other plants, there could be some really undesirable things happen if you let vines grow. But if you give a vine a trellis to grow up, the vines are going to grab onto the trellis and grow into the shape you want. So this same principle applies to the use of scaffolds in tissue engineering. So think of the scaffold as the trellis and the cells as the vines. The scaffolds is the shape that the cells use to grow, and then they spread appropriately within that scaffold. And without a scaffold, the cells might follow the natural contours of the human body, which could create some undesired effects and shapes depending on what you're doing and what your goals are. So Vacanti and Langer applied this idea in a very interesting way. So in 1996, the Vacanti mouse was created. Charles Vacanti, his older brother Joseph, and they're both regarded as the fathers of tissue engineering, and Linda Griffith of MIT, as well as the aforementioned Langer, they worked to create this mouse. So this laboratory mouse appears to have a human ear growing out of its back. The image is pretty grotesque, but don't worry, the ear isn't actually a human ear sewn onto a mouse. That would be really weird. The ear was actually an ear-shaped cartilage structure grown by the seeding of cow cartilage cells into a biodegradable ear shape. So the cartilage structure was placed under the skin of the mouse, and an external splint was helped to maintain the ear shape. The cartilage grew naturally, and then boom, you have an ear on a mouse. The external splint was removed briefly to take pictures and stuff. Tissue engineering was being talked about before the Vacanti mouse, but something as shocking with a mouse with an ear on its back boosted the spread exponentially. So pictures of the mouse were spread via email, often with no context to the public. This prompted some backlash from the public against genetic engineering, despite no genetic manipulation being done. But regardless of that, the efforts to define the field of tissue engineering were located mainly in Boston, where the Vacanti brothers developed the mouse. And then from then on, the tissue engineering efforts were popping up all over the United States. For example, the Pittsburgh Tissue Engineering Initiative was organized in the 1990s. Laboratories were being overseen at Rice University in Houston by doctors Antonio Mikos and Larry McIntyre, as well as cardiovascular tissue engineering efforts were being made at Georgia Tech. So the spread of tissue engineering became international very quickly. Dr. Julia Pollock, a pathologist and stem cell biologist in London, organized a British-based society that developed a loose association with the Tissue Engineering Society that was created in Boston. Dr. Una Chen conducted tissue engineering and stem cell studies in Germany. Dr. Clement Ibarra conducted tissue engineering and stem cell studies in Mexico City, opened laboratories in Mexico City, and founded the Mexican Tissue Engineering Society. Dr. Wolfgang Pulitzer opened a laboratory in Austria at the Leopold Institute. A tri-state effort between Germany, Switzerland, and southern France to create laboratories were spearheaded by many of the doctors at the University of Freiburg in Germany. And by the late 1990s, all of these were starting to develop and become, actual viable things. And there was a lot of collaborations being established across the pond, if you will, between the Children's Hospital in Boston and cardiovascular surgeons and transplant surgeons in Berlin and Hamburg, respectively, as well as a group from Asia at Kyoto University was also invited in this collaboration. Large-scale tissue engineering efforts were taking place in Japan, and these were being spearheaded by doctors at Nagoya University, and they organized the first meeting of the Japanese Tissue Engineering Society in 1997. And surprisingly enough, the Chinese government sponsored tissue engineering efforts in Shanghai. And tissue engineering is, a big deal if the Chinese government wants a piece of it. At the turn of the century, tissue engineering efforts were popping up in essentially every developed country, as well as several privately funded initiatives within those countries. So now that we've learned a little bit about how tissue engineering came to be and how it spread across the world, let's talk about what is currently happening in the field today. So when I was working on this section, I simply Googled best tissue engineering companies and found some startups that interested me, some of which don't actually exist anymore, which is kind of sad because a lot of them were doing really great work. But a lot of the reasons why they dissolve, I'll get into a little bit later. But I'm just going to talk about some of the work that interested me, even if they aren't currently being worked on. So one company that doesn't exist anymore, but I thought was doing really fascinating work, was Lattice Medical of Loos, France. They closed their last funding round in 2018, so they've been out of the business, so to speak, for about 4 years. But they were making 3D bioabsorbable breast implants for women who had undergone a double mastectomy due to breast cancer. And I think the work that they did is really important because women's health is like a chronically overlooked sector of human health. And the work that they were doing was aiming to help badass women who survived breast cancer regain their femininity and have reconstructive surgery, for their own reasons. But I just think the work they were doing was super dope. So 3 women, a mother and 2 daughters, paired with Julian Payen to create Lattice Medical. So the implant works a little bit like this. So the implant is a 3D printed shell or scaffold made up of bioabsorbable structures. So by bioabsorbable structure, I mean that it's made up of material that can be absorbed into your body. Then a small sample of adipose tissue or fat tissue is placed within the shell. And then through surgery, the shell with the adipose tissue inside is placed within your body, and they promise in 4 to 8 months that the adipose tissue grows and fills out the breast to the desired shape and size. And 1 year after the surgery, the shell implant made of the bioabsorbable structures will completely dissolve into your body. And I think this is a really cool concept, and I hope, the technology gets picked up again, there's proper funding for it, and the idea is continued and then eventually perfected. The original creator, Julian Payen, wanted the procedure to be comparable to the price of a regular silicone breast procedure, and although no official cost breakdown was done, it didn't look like it would be a cheap procedure. There are a few other drawbacks to the 3D bioabsorbable breast implant that don't include the cost, like the surgery. The surgery is going to take about 7 hours, and then you might have to do additional surgeries on top of that, in which for frailer patients, that is just not an option for them. There's a few other drawbacks, but I think in general, this is a really great idea, and I really hope somebody picks up on it and continues work like that. So another tissue engineering product, so to speak, doesn't really belong to a specific company, but it's more so the whole industry, and that is organs on a chip. So organs on a chip, or OOCs, are miniature tissues and organs grown outside of the body that model human physiology and disease. So I like to think of it just that they're a collection of cells arranged in such a way that represent a simplified but realistic structure of their organ level counterparts. So they're not like literal miniature organs on a chip, but they're just a collection of cells made to mimic their organ counterpart. So like a mini lung or a mini heart. So OOCs are typically used for drugs and treatments being tested on them. And hopefully this will completely eliminate the use of animal testing. Animals are already a bad surrogate to, test on because their physiology is so different from ours. So the use of OOCs will shift the focus away from animals and onto human testing. But not human testing in the way you might think. OOCs are better than human testing because you're not testing on live humans. You're testing on a model that would replicate what a human would respond with. So OOCs are being used for drug efficacy in the treatment of cancer. And there's been lots of success in curing cancer for mice, but that success hasn't transferred over to humans. So through OOCs, we might be able to find the cure to cancer. And like, how insane is that? I don't know, I think it's pretty cool. And the 3D bioabsorbable breast implant, although it doesn't exist, is still like really cool, a really cool product, hopefully, that we could have or have something like this. OOCs, the same thing. It's like such a cool, inventive, insane product that is, being developed. But unfortunately, a lot of products being developed can be really hard for patients to get for actual clinical use. A lot of that is because of funding as well as FDA regulations. For example, Dermagraft and Apligraft were severely impacted by a guideline proposed by the Center for Medicare and Medicaid Services. So under the new guideline, tissue engineering products were placed under the same category as a cheaper and more simpler product. And so this resulted in a much lower reimbursement percentage. So hospitals were discouraged from using the more expensive, technologically advanced tissue engineered products because it would result in a financial loss for the hospital. So in the case of Dermagraft and Apligraft, patients who suffer from diabetic foot ulcers or venous leg ulcers were left without a revolutionary treatment that can completely close their open skin lesions. Oftentimes when these lesions go without treatment or even like pretty good treatment, sometimes they're just stubborn, amputation of the limb and even death can occur. So access to tissue engineered products can be a matter of life and death for some people, and we know that there's a continuous push from the industry to put products out on the market, but external factors like FDA regulations really affect product sales and ultimately patient lives. Some, if not most, of all tissue engineered products rarely make it past the clinical trial stage and into an actual product. And lots of ideas rarely even get to the preclinical stage. Regulations are being put into place that make it hard for actual products to get into the hands of patients, as well as the ongoing economic crisis due to the pandemic has really halted the industry. It's made investors wary to invest in the tissue engineering industry just due to the economic instability. As of 2021, only 10 tissue engineered products were available in the whole world. And I agree that's not a lot of products. It's a pretty dismal number. And with everything going on, the odds just don't seem to be in favor of the tissue engineering industry. So is the developing industry really ready for the future? Laura Nicholson, founder and CEO of Humacyte, which is a biotechnology company that targets life and limb-threatening vascular conditions through acellular tissues. Laura is a professor at Yale, a physician, and an internationally recognized researcher in lung and vascular tissue engineering. She believes that tissue engineering is suited for the future. She states that she has been in the regenerative medicine and cell therapy industry for a long time, but in the beginning it did seem like science fiction. But now we're at a point where the advancements in tissue engineering are scientific fact. Jason Foster, the CEO of Ori Biotech, a cell and gene therapy manufacturing company, agrees. He says that there's no need to make a case for the cell and gene therapy industry. It's proven time and time again that we can create cures for the most devastating types of cancers and rare diseases. Instead, the industry needs to go through a paradigm shift to allow for the correct infrastructure to be put into place. So once the industry has expanded and we have a good infrastructure, a good foundation laid down, the tissue engineering products will follow. I am a pretty impatient and stubborn person, and I'm thinking, will I get to see the cool tissue engineering products I've read about in my lifetime? And I'd like to think so. The process is pretty slow going, and it's going to take a lot of effort from all types of people in the tissue engineering industry to put more products out. But I'm optimistic that as the economy begins to stabilize and more investors are willing to invest money into the industry, that will hopefully spark the shift needed to make products more widely available to the public, and I can see all the cool stuff happening. The last thing I want to talk about today is the ethical debate around tissue engineering. And while I was researching for this project, I reached out to a variety of startups from across the country, and I asked them about any specific pushback they had received in regards to their work. I heard back from a whopping 0, And although that's not really surprising, I didn't hear back from anyone. It's not going to deter me from talking about some of the ethical concerns on a more broad scale. And so for this last segment, I'm going to go off script and just talk about some of the ethical concerns regarding tissue engineering and my opinions surrounding them. So one thing that's kind of talked about in terms of like the ethical considerations for tissue engineering is, is there too much playing God? Is it unnatural? Is it like a weird dystopian thing? And honestly, this is just my opinion. I think it's honestly one of the most natural types of medicines. Like you're taking your own tissue in some cases, but you're taking human tissues and you're developing them to suit your needs. And you're basically using your own tissues to repair your body, which is like one of the most natural things to me. In terms of like playing God, I think it could be borderline maybe playing God, but I think that if there's a good checks and balances system that, so that there isn't any major abuses of power. I was actually researching a little bit, and a lot of people involved in the tissue engineering industry actually want more, guidelines from the government in terms of like how to ethically run, trials like this, since it's so new. There already are things that exist, and obviously like consent across like all parties in a trial, like those things already exist, but people in the tissue engineering industry want more guidelines to follow, partially so that a decision you made doesn't, bite you in the butt later on. But overall, I think that, you could play God a little bit too much, but hopefully there's some government intervention where there is good guidelines and good checks and balances to avoid any abuses of power. When talking about the government intervening in lawmaking for this type of industry, I personally am of the opinion that a lot of government officials might be scared of this, or they just might not be completely informed about it, and so they might not make the best decisions for the industry. This is just my opinion, and it's just like a hypothetical. But I think if the government is going to intervene, they should be, collaborating with industry professionals and really working to make good regulations. I don't really know what else more to say. I just think that governments should work really closely with people within the industry so that they make regulations that make sense, and they're kind of avoiding what I mentioned earlier about putting tissue engineered products in a category that doesn't fit them. So, and hopefully down the line that means, increased access, lower costs. I just think, with the government being involved, you just have to be careful with what they're doing. And I just think they need to be collaborating with industry professionals to make the best informed decisions for the industry. I'm someone who obviously is like pro tissue engineering. I'm like more on the positive side, obviously, because I'm interested in the field. I don't know. That seems kind of like a given. But one thing that I'm a little bit concerned about is how this might contribute to overpopulation. The Earth is overpopulated, and there's plenty of people on the Earth, and we have a lot of health challenges related to people living for longer. And I think the tissue engineering field might be contributing towards the problem of people like living too long. Like let's say hypothetically you have like a damaged heart valve and you need a tissue engineered heart valve to like repair or replace that valve in your heart. And so if you replace or restore this heart valve to its like maxed out potential, you like make it as good as new, so to say, you might be extending a person's life for quite a while, if their heart valve is what's causing them to shorten years off their life, and you repair it, you might extend their life, which is like, all fine and dandy. I love saving lives, but people might be living for longer. That was weird. People might be living for longer, and that causes a lot of problems in our Earth and other health-related challenges. And you gotta die someday. So I'm just thinking it might contribute to overpopulation and some other health risks associated with just being alive for longer. I obviously don't know like the nitty-gritty of it, but I just foresee that being a potential problem. It might not be, but I think that is a valid concern. And I mentioned a little bit earlier how like there's lung and vascular tissue engineering, and there's a bunch of subcategories underneath tissue engineering itself. I think one thing that I kind of avoided talking about was stem cell tissue engineering, particularly fetal stem cell tissue engineering, where we use stem cells typically from like an aborted fetus. Oh my god, the dogs are yelling. Oh my god. Anyway, I kind of avoided talking about it just because it is sort of a touchy subject. But personally, I believe, and science supports, that during pregnancy, it's just not viable, before a certain point, and that I think if a pregnant person decides to make the choice to abort the fetus, that maybe those cells could be used for tissue engineering. Once again, I'm not an expert. I don't really know exactly how it works. But I think that using fetal stem cells really isn't all that bad, and particularly because there is so much limitless potential. Fetal stem cells are, like, there is so much potential. For example, like a fetal stem cell has the potential to grow into so many different types of cells. It might be a skin cell, it might be a muscle cell. It's not hard to explain, but I'm gonna try. So like a fetal stem cell has like the potential to become like a human baby. Like that's pretty crazy. Okay, I'm realizing that if you can hear my dogs in the background, sorry, they're just loud. Sorry, if you hear my dogs, just ignore them. Basically, like, if I were to pluck a skin cell, off right now, it's only going to grow and be a skin cell. It's not going to turn into I don't know, it's not going to turn into any other type of cell. It's going to be a skin cell. But with fetal stem cells, they have the potential to become a skin cell, like a muscle. It can become anything, and I think that is some really untapped potential. And I don't really want to get into too much like abortion, life begins at conception type of speak, but we can talk about it. I just think for the sake of this video, I should keep it short. But I just think there's a lot of potential there, but there is a lot of like ethical and moral considerations that go into it, and that everyone's going to differ on it, and so I think that polarization is going to make it hard for any like real things to come of it. But I'm optimistic. Maybe there'll be something. I don't know. I think fetal stem cells for the most part are pretty good. We just need to be careful with the future. Okay, now that I'm done blabbering on about my opinions and such, I just wanted to thank you for watching this video. I really appreciate it. If you're one of my classmates watching this in class with me right now, I encourage you to ask a bunch of questions, talk about the ethical debate. What are your thoughts on some of the things I brought up? What questions, kind of spiral off what we talked about. I really encourage all of us to have a conversation around this, and that's like the goal. I wanted you to learn something. I want you to be excited about this subject. I want you to talk about it, and I think hopefully I met that goal. So thanks again for watching this video, and if you are a random person on YouTube who found this video, 1, how, and 2, feel free to comment your thoughts and your opinions as well. There's always room for discourse and communication in the comments below. Okay, thank you for watching this video. I appreciate it. I hope you learned something. All right. Goodbye.